Good afternoon. Assalamualaikum. Okay, so today I will start a new chapter, which is chapter 5, differentiation and integration. I will start with integration first. Okay, but here in numerical, we will not be doing the analytical integration that you need to integrate using the sign, right? But in this topic, we do it numerically. We use formula. Okay. Okay, as you all know, integration is the inverse of differentiation. After we have learned the integration, then only we will go for differentiation. Differentiation in numerical is much more easier. Okay. Okay, for integration, usually you will need to identify the area under the curve. Okay, let's say you have fx, function of fx. Quite small, huh? Let's say you have a function of fx. Okay, so you will need to identify what is the area under the curve for this function. Okay, if linear line is easier for us to identify if linear. Okay, you just identify 1 point, 2 point. So from here you can find the area under the curve. All area under the curve will be calculated. Okay, but if you have, are you in the correct class? Numerical. What course? Mr. Bona, is it? Try to contact him. Whether it's in the lab or not. I changed the class with him. Okay, if linear line is easy to find the overall area under the curve. But if it is non-linear, be it quadratic or cubic or sine, cos, you will have some error. Okay, let's say, for example, if you have this point and this point. Okay, and then you need to find area under the curve. So you need a specific formula to find all of this. If you apply the, for example, this shape, you'll have some error. Okay, let's say only this part calculated. So this part is another area that is not covered, which considered as the error. Okay. Okay, I'll go through slide by slide so that you can understand. Huh? Now for integration, Newton Cotes integration formula, we have trapezoidal, Simpson's rule, and unequal segment. Okay, trapezoidal, it is based on the trapezoid shape. Trapezoid. Still remember how trapezoid looks like? Trapezium, where you have different same base. Sorry. Okay, you have base, and then you have one height. Okay, so we will use this trapezoid concept in calculating the area under the curve. Now, Simpson's rule, similar to trapezoid, but it has 1/3 rule and 3/8 rules. Okay, and it has its own formula. Okay, all of this is to find area under the curve. Unequal segments mean when you have different step size. For example, let's say this is the curve from point A to point B. Okay, if trapezoid, this is the trapezoid shape. Okay, then you have unequal segment, meaning that perhaps you will have different height over here, h, or different segment, okay, or different fx value. Okay, at this point, this is the fx naught. Here, fx1. Okay, so this is unequal segment, where for unequal segment, we can mix the application of trapezoidal and Simpson. You can use both methods to calculate the area under the curve. Main target is to calculate area under the curve. Okay, is it hot in here or just me? Okay, it's just no aircon come here. Okay, now for integration, we will integrate based on the function. Still remember that we do the function, this one, fnx. fnx, where you have, if Newton one, okay, Newton, you have b naught, b1x, x1 plus b2, x2, until n, x power n. Okay, so this kind of function that you will be using to find the area under the curve. Okay, now a here referring to the b naught last time. Okay, doesn't matter what letter that they use, the meaning is the same. Okay, a naught or b naught, this one b1 up to bn. What is the meaning of the n? Order, right? N is the order. Okay, in integration, n equals to order, and also n equals to segment. Okay, so let's say it said calculate the integration for n equals to 4, meaning that the function, the curve, have 4 segments. Okay, 4 segments, n equals to 4. So you have how many points? 5 points, right? 5 points. Okay, x naught, x1, x2, x3, x4. That is your points. Okay, before this, you are given the points and also the function. But now, using that points, you will interpret it into the area under the curve, the trapezoid shape. Okay. Okay, for example, when we have here a first order polynomial, first order, n equals to what? 1, meaning you have how many points? 2. Okay, 2 points. This one refer to this. So here n equals to 1. 2 points. So here is your point. X naught, x1. Okay, so here is your fx naught. And then this one is your fx1. Okay, so here See the function, the curve here is the function. Fx function. Okay, maybe this is a quadratic function or cubic function. Okay, now it asks you to find area under the curve by using first order. First order 2 points. You only have 2 points, meaning that one segment. Okay, here you see one trapezoid. So these 2 points, fx0 and fx1, is the connecting point for the trapezoid. Okay, you have only one shape of trapezoid. That's why n equals to 1. Whereby the actual area under the curve is the one that covered in yellow color. Okay, but using the function numerical integration, we only cover this area. We only can calculate this area. Okay, so the rest of the area, this part, is error. The error part. Okay, which is not being calculated numerically. So n equals to 1. Okay, what happened if n equals to 2? Second order. You have 3 points. N equals to 2, meaning that you have 2 segments. Okay, so x0, x1, x2. So x0, x1, x2. You have 2 segments. Now you see the trapezoid now. You have 2 trapezoid, 2 segments. So you can see the calculated area under the curve is bigger compared to n equals to 1. Okay, then the error, as you can see, the error reduce. This part only the error, which is not covered by the trapezoid. Error reduce with increasing n. When n increase, error reduce. Okay, get the concept? Now, how to find the actual area under the curve? Using calculator. Do it integration using calculator. Then you will find the true value. Okay, calculator using the integration. Later we'll do exercise. Compare between the numerically calculated and actual value. Okay. Okay, so far can get the concept. Huh? What is the integration? Similar, this one similar. Okay, here when you have more segments. Okay, as you can see over here, more segments will reduce the error. You can go up to n segment. Depends to your step size. The target, the main focus is to find the area under the curve with the lowest possible error. Okay. Okay, let's say here, for example, integrate this function where f1x n over here, sorry, 1 over here is n equals to 1. Okay, so that's why it involves only 2 points. X0, x1. Okay, here x0, x1. This is the equation from Newton last time, right? Newton differentiation. Sorry, interpolation. Okay, where this is the one that you need to calculate, the B1 last time. This is B0. Okay. Okay, it doesn't matter what letter you use, either X0 or A, X1 or B, as long as you understand the concept. Okay. Now moving forward, this is the function comes from this order. Okay, f1x. So this is the expanded equation. So you need to integrate it to find area under the curve. But using integration, numerically integrate, we use this equation. This comes from the trapezoid formula to find the area of the trapezoid. Okay, where B minus A, yeah, okay, this area. B minus A is the length. Here is the height if using trapezoid. Okay, so this one is the base, FA, FB. Remember the trapezoid? You have F, for example, base 1, base here. Then you have the height. Okay. Height multiplied by the average of the base. This is the trapezoid equation. Area of trapezoid. Okay, that's how this equation comes in. Okay, this one, if you have only one segment, n equals to 1. Okay. Okay, this is to calculate the error of the trapezoidal rules. For single application, means n equals to 1 only. If multiple different equation. Okay, but I will not emphasize too much on this equation to calculate the error. Okay, because here it involves, you see, double differentiation. It involves double differentiation. So I will not emphasize too much on this equation. We'll go the easier way. Okay. Now we try this. This example extracted from the textbook. Single application. Okay, single application means n equals to 1. Use equation 21.3, this one, to numerically integrate the given function. Okay, this is the given function fx. From a0 to a equals from a0 to b 0.8. A0 to b 0.8. This one for example only, not the actual slope, not the actual shape. Okay, for example here, n equals to 1, so one segment. A0, B 0.8. This one is your point. X0, X1, right? So 0, 0.8. Now you need to find Fx0 or Fa. Using, how to find? Using this function. Okay, try to calculate what is your Fx0 and Fx1 using this function. Fx0 or Fa 0.2. F0, correct, 0.232. The rest get the same? Tasmia, you get the same. Ruben? Okay. Now it asks you to integrate, where we know integration involve a, b, f, x, f and x, dx, right? Now here, a here is 0, b is 0.8, from 0 to 0.8. Your fx here is given by this. Okay, always find what is your fx. Sometimes it doesn't give you the equation like this. It just straight away give you the numbers. Okay. Now, to integrate numerically, we know that the equation, it is this one. Here, this equation. B minus A multiplied by FA plus FB over 2. Okay, subs the info, subs the value. B is 0.8 minus A 0 multiplied by FA or Fx0 0.2 plus 0.232 over 2. What you get? 0.1728. You see from the statement here, it already mentioned, and then analytically, the value is this. How to get this? Press the calculator. You know how to press the calculator for integration? Wait, let me show you. Okay, the main thing is the function. Integration, press this one. Okay, then key in the function over here. 0.2. Key in the equation as usual using alpha x, then minus 200. Okay, key in the function first. Okay, up to there. Key in the function. Up to 400x power 5. Okay, then comma. Key in comma. Then you input the range A and B. 0 is the A, comma, B. B is 0.8. Close bracket. Okay, then press equal. In your calculator, sometimes once you press equal, you need to wait for some time, for a few seconds. You get the value, Ruben? Using calculator. Get the value. Okay, now compare with the one that you get numerically. Two big difference. Okay, because it's only one segment. That's why you have a big error over there. So to calculate the error, ET, we use symbol ET. ET here is true value minus approximate value. Not yet the percentage. Okay, if the percentage, as usual, the true error percentage, PV over minus approximate value over TV multiply 100. Okay, try to calculate what you get for ET. Not the percentage yet. 1.4677, right? The error is big because only involve one segment. How about the percentage? Correct. 89.5. The error. Only using one segment. Remember, the one that I draw here is not the actual curve. Okay. Okay, before I move to the next slide, to answer this question, this example, your answer is up to here, the integration value. Okay. This is the actual curve of this function. Actual curve of this function from x0 to x0.8. Okay, here you can see the estimated area that we calculate just now is only this part. That's why you get two big errors. Okay, this whole thing is the error. Remember, n equals to 1, so involve only one segment. Okay, you understand the concept now? If one segment is very big error. Now I'll show you how many segments it requires to reduce the error. Here. It uses multiple application. N here refers to the segment. Okay, so you can see up to 10 segments. Then only the error reduced by 1.6%. 10 segments, so meaning that here just now is only one segment. So it divide into 10 segments. Okay, let's say 10 lah. Okay, so you can see from here the error will be reduced a lot because it involves many segments. It covers a lot. It covers on the error part. Okay, so perhaps only left out this part. That's why with 10 segments, only 1.6% error. Okay, get the concept? between one single application and multiple application. Okay, for n equals to 1 just now, we didn't need to calculate the h. H means the step size. Step size is the distance between point x0 to x1, the height, in order to calculate the trapezoid. Okay. Now, if you have multiple, means we use many trapezoid to calculate the area under the curve. Okay, here you see the curve. The more the area, the lower the error. If two segment, can see here the error. Okay, the difference. So it reduces with increasing area. Okay, this one we focus on trapezoid only. Single trapezoid and multiple trapezoid. Now this is the equation to find using multiple application. This to calculate area 1, each area, to calculate each area. So this one up to calculate area n. So we mix up all together, sum up the area. Okay, when you have multiple, you'll see h over here. H here is the step size, where the equation to find the step size is this one, b minus a over n. Okay, this is the h. Still remember in chapter 2, to find the root, you are given the step size, right? So in that topic, you are given the step size. In this multiple, you will need to find out what is the suitable step size to reduce the error. Okay, so this is how to find the step size. Okay, when you have n segments, the overall equation of multiple application, this is the overall equation. B minus A multiplied by fx naught, the first area, plus the intermediate area, then plus the final area. Okay, let's say you have up to n. N, this is n. This is x naught. X naught, okay, fx naught is the first one. Fx naught. Here is the intermediate. Fxn over here. Okay, the final one. Fxn. Okay, so the intermediate area over here is this part. Summation of the intermediate area. Then divide by 2n. Okay. Here you see b minus a, then over 2n. But here, it is h, it use h. Okay, don't get confused because the h over here is b over a, b minus a over n. So here, b minus a over n, take out this n, then you'll get h over there. Okay, now we do example so that you can understand. It asks you to find the integral for the following function for n equals to 4. Means you have 4 segments. How many points? 5. So you will need to have x0, x1, up to x4. Four segments. Okay, then the range given, your A is 2. This is your A, this is your B. A, B. Okay, remember A is your x0, initial point. B, x4, the final point. First thing first, you need to find what is your x1 until x3. x0, you have the value, which is 2. x4 is 6. Okay, how to find this x value? Huh? That's when h comes in. Step size. Step size is the difference between 0.1 to 0.2. So h over here, try to calculate what is your h. Hmm? 2. Correct, 2. H. 1. Should be 1. B 6 minus 2 over 4. N is 4. Okay, h will get 1. How to find x1 from here? 2 plus 1, correct. So x1 equals to x0, the initial point, plus the h. So x1, that's how you get 3. 2 plus 1 equals 3. Because we want to find the next point. Step size is the h, okay? So x2, 4. x3, 5. The equation to find the step, the next point, something like this. I plus 1, xi plus h. Okay, on the x point. Now calculate your fx. I move to the next slide. Okay, here. Axis has been identified. Now calculate your fx. How to find the fx? This is the function given. This is your fx. Square root. So fx square root of 2. Square root of the x. Okay, you get the same, the fx value. Once you obtain all the x and fx's, subs into the integration equation. Okay, this one. This is the main equation for multiple application. B is 6 minus A is 2. Then fx naught is the first point. Fx naught plus 2 multiplied by the summation of the intermediate part. Okay, so here, this part. Summation of this, the green color one. The fxn is the last part, the last area. Regardless of how many segments, the intermediate should be summed up, multiplied by 2, the fx. Then divided by 2, multiplied by the n. N here equals to 4. Okay, try to calculate whether you get this value or not. Okay, get. Okay, 5 minutes for you to digest. Let me know if you want me to repeat or if you don't understand. Or just keep quiet. I don't know whether you understand. I used to have a class of very first grade. Okay, let's try this for multiple application. The same function as the single application. it asks you to use 2 segments, means n equals to 2. You need 3 data points. The range is still the same from 0 to 0.8. Okay, first thing first, we need to find what is the step size in order to identify your point. Step size, b minus a over n. What you get? 0.4, right? 0.4. Then identify your points, the axis and also the f-axis. X0 is the starting point, 0. X2 is the last point, 0.8. Okay, so X1, 0 plus 0.4. The fx0, in the previous example, we have obtained 0.2 and fx2, 0.232. How about fx1? What you get, Alif? Correct. $2.456. It looks weird because it is out of the range, but yet check out on the function. Okay. Now from there, proceed to step 3, subs all values to find the integration for multiple application. Here, instead of you sub in b minus a, you can straight away sub in your h. (0.4). But then this one need to remove lah. It's up to you how you choose which value to subs. This one, inside here, just divide by 2. So fx0, 0.2. 2 multiplied by the intermediate. So intermediate part here is only one value. 2 multiplied by the fx1 plus fxn and divide by 2. What you get? Right. 1.0688. Compare when you use n equals to 1 previously. When n equals to 1, the segment is 0.1728. Okay, so there are difference. Okay, let me clarify again. This part, don't get confused. This is the original equation. Okay. For multiple. The 0.4 there, how I get is 6 minus, not 6, sorry. Different example. 0.8 over n segment. 2 here is the n. I bring out the n over here, outside. Okay, so this part is equivalent to the h. B minus a over n. Okay, take your time to understand. Okay, can we try this one last question before we stop the class? It asks you to evaluate the following integral. Now, the function here is more complex. It involves the cos. Remember, every time function sine cos tan, please use mode radian. Okay, now analytically is using calculator. This is to find the true value. Okay, we try for B first. Single application. N equals to 1. Trapezoidal rule. Okay, you see D and E, it use Simpson. Now for B, specifically using trapezoidal rule. N equals to 1 means you have only one segment. So this is your A, 0 is your A, pi over 2 is your B. Okay, so as illustration, for you to understand, A, B. So we only have one segment. Trapezoidal rule. Okay, A is your x naught, which is 0, x1, which is pi over 2. Okay. Equation to find the integration using single application. B minus A multiplied by FA plus FB over 2. Okay, so in order to use this equation, you need to find what is your FA and FB. How to find FA and FB? Using the function over here. Okay, so using this function, sub in 0, then you'll get a value. FA should be 12. Radian mode, right? Okay, radian mode, you get 12. FB sub in pi over 2 over here for the x. So you will get 11.9985. Correct. Or you get 8. 8. Perhaps this one is different mode last time. 8. Okay. Then sub in the value into the equation. Let me know what you get. Sorry? 5. 5.1. 15.7. 15.7079. We get the same? Remember radian mode. If you use degree, you will get different answer. Okay, everyone can get? Ruben, can you catch up? Okay, so tomorrow we will continue on the multiple. Maybe you can try on your own what you get for multiple. Then I will proceed with the next example. Okay, there are a lot more. Here. This one final exam May 2021. Okay, so tomorrow we will do exercise on this trapezoidal rule. Okay, so that's all for today. Thank you.